Good night, sir. I sent you a message. If you could please look at it from yesterday.
Sir, yeah, talk, I say something. Nah, yeah, I think you can say something.
Hi. Yes, please, John. I wasn't speaking at the time. I was just trying
Hello,
to.
sir.
We're doing boss. Well, all right. Good afternoon. Good evening again, students. Um. Yes, Lotta. Thank you for the reminder today about the stuff. Um. You'd have known by now that I upgraded my device, and unfortunately, the new device does not have the software on the stuff, which is why I have resorted to doing most of the writing instead of projecting the notes. I still, however, type my notes because the handwritten notes, you know, it's not as neat as the type notes, and the type notes can, whatever it is, last a longer time, etc., etc. So I'm still trying. The last time I screenshot the stuff and posted it in the document, it didn't come out as clear as I would have wanted. So bear on with me. Lotto gave me the reminder today. I'm fully aware of it, but I'm trying to circumvent the challenges that I'm having in just doing that. So forgive me. It will be done, but please. I should let you know that I think Crosswell told me that they they both charger and battery for the old computer really may need to change. So I actually purchased a new battery and charger, and I'm really hoping, well, it's not yet here, but I'm hoping that when it comes weekend, God's willing, I'll be able to get back to my files and stuff because I can't use a computer none at all, and my files are just there with the computer asleep. So just bear on with me. You will get it. I'm going to get it to you. Yes, I know exams are coming up. I'm going to get it to you. I promise you that. All right. Um, it took me a while to find this, what I'm projecting to you just now, because one of the things that I wanted to do, I left the class last night not feeling comfortable that you guys knew how to do the factorization. And in my headspace, I believe some of you would have said, okay, I understand how we substitute the critical values into the D formula in order to find out that it's a maximum or minimum, but I still don't know how you factorize it. So allow me to just walk you through now with the factorization. And this is just to really help you to see what is happening. Courage asked a question yesterday, and I told her that we need to prime factorize. And I think some of you may not um, remember or know what is this prime factorization that I speak of. When you multiply 3 by 484, what do you get? Is it $484? 484. When you multiply 3 by 484, what do you get? Is it 1492?
1452.
1462
52.
or 1452? All right, so 1452. Ouch. What is wrong with me? 1452. I'm showing you how to do prime factorization. So when I'm prime factorizing, it means that I'm going to be using my prime numbers to do my factorization. The first prime number is 2. So 2 into 1452 goes 726. Tell me if you agree with me.
Yes, sir.
And then 2 into 726 is going to be 236. 2 6 is 12. Is it 636?
There is 633.
3
363, sorry.
363. All right. Can I divide that by 2 again?
No, you have to divide it by 3.
Right. I'll go to the next prime number, which is 3. And I'm going to get 121, don't?
Yes, sir.
What's the next prime number into that?
11.
No.
No?
Is it 11? Sorry.
It's not 11.
Yeah, 11. And then you have 11 times. And then 11 to that goes 1 time. Agree?
Yes, sir.
Same.
Somebody said, sir?
No, I said same.
Okay, cool. Um, right. Now, in order for you to get your factors, you have to.
Sir,
Yeah. Yes, sir.
no, mind me silence me. They on the road thing here.
All right, Papa. Um, one of the things that we're going to do for this one now is to manipulate. Just make sure you're I hope you're not driving. Um, if you're not driving, just pay attention. Watch your screen. If you are driving, just listen to me. Please do not watch your screen while you're driving, Papa. Want you to be around. All right. So we're going to manipulate. These are my prime factors. 2 times 2 times 3 times 11 times 11 will give me 1452. So I'm going to be manipulating my prime factors. So I will say something like 2 times 2 is 4. 4 times 3 is 12. 12 times 11 is going to give me 132. But when I have 132 here, when I subtract 11 from 132, I'm not going to get 88. So if I say 11 times is 22, 2 times 3 is 6, and 6 times 11 is 66. 66 and 22 will give me 88. All right. So
I'm sorry, please repeat that.
okay, so I'm saying these prime factors are what it is that I'm going to manipulating. All right, so let's go from here. I need 2 numbers. I'm going to multiply the coefficient of y squared by the constant. So I'm multiplying 3 by 484. Multiplying the coefficient of y squared by the constant. 3 times 484 will give me 1,452. Forgive me. So I'm multiplying the coefficient of y squared by the constant. Now, when I multiply the coefficient of y squared by the constant, I'm going to be given 1452. In order for me to find the prime factors, I'm going to divide by my prime numbers. Only prime numbers. 2 into 1452 goes 726 times. 2 is also a factor, so I divide by that. It gives me 363. 2 is not a factor of that, so I move to 3. 3 into 363 goes 121 times. And then the next prime number is 5, but 5 is not a factor of 121. Then 7. 9 is not a prime number. The next prime number after 9 is going to be 11. But 11 can go into 121, and it does so 11 times. And then 11 into 11 goes 1. So what I have is 2 times 2 times 3 times 11 is going to be equal 2 times 2 times 3 times 11, or I can write it as 2 squared times 3 times 11 square is equals to 1452. 1452. All right. Now, that 1452. Now, what I'm going to be doing is looking at these prime numbers, these numbers here, and I'm going to manipulate those numbers to find two numbers. Hear my story. I need two numbers. When multiplied together will give me 1452, but when added gives me a negative 88. Two numbers when multiplied together will give me 1452, but when added will give me negative 88. So therefore I need to manipulate these. I'm saying 2 times 2 is 4, 4 times 3 is 12, all right? But 11 times 11 is 121. If I have 121 minus 12, that's not going to give me 88. So I have to move on. If I say 11 times 3 is 33, I'll have 33 written down. Then 11 times 2 is 22, and 22 times 2 is going to be 44. 33 plus 44 is 77. Don't want that, I want an 88, right? So I'm going to say, okay, what about, I multiplied 3 by 11 already. What about multiplying 2 by 11? 2 times 11 is 22. This 2 by this 11 will give me 22. So I'm going to have 3 times 2 left times 11, which is 66. So 66 plus 22 will give me 88. Can you see how I manipulated those numbers to arrive at my 66 and 28 and 22?
Yes, sir.
Yes, sir. Understood now.
Right. So
Sir,
it's
long
just,
time I play maths there.
say it again, Papa.
I say a long time I play maths there, sir.
All right. Yeah, man. So it's just a manipulation. It's not that many, but the prime factorization, however, is the quickest method that I have come across. And I have been doing this much from about third form. Okay, let's not find out how long ago that is. But yeah, man, it's been a while. The prime factorization is really and truly a quick method, right? The other methods are fine when you have smaller numbers. But for sure, when you have big numbers like these, prime factorization, easy, easy, 1, 2, 3. All right. So it's just a manipulation of your prime factors here that you just play around with them. 2 times 2 is 4. 4 times 3 is 12. Rockstone. 12. But 11 times 11 is 121. 121 minus 12. Not going to give you 88. And you just play around with them, and you trust me, you'll find the factors in quick time. All right. So my factors are going to be 66 and 22. Now remember, I need a negative 88, but I also need a positive 1452. When this sign is a positive sign, it says to us that both signs in the brackets are the same, and the signs going to look like this sign. I know that from I see the second sign being negative, I know that my two factors are going to be negative. Once the last sign here is a positive sign, it says to us that both signs in the brackets are the same, and it's going to take the color of this sign. All right. So if this sign is a negative sign, it means that one of the factors will be negative and the other factor is going to be positive. But the mere fact that this number here is positive, it means that they are going to look like this sign. So I'm going to say now that, let me just, 2 times 11 is equal to 22. And then I'm going to say 2 times 3 times that. 2 times 3 times 11 is going to be equal to 66. And then I'm going to say no. I'm going to say negative 66 minus 22 is equal to negative 88. All right. So factors are negative 66 and negative 22. Watch me now. I'm going to say 3y squared minus 66y minus 22y plus 484 is equal to 0. Then I'm going to group to say 3y squared minus 66y in one bracket, leave my middle sign out every time, and then I am going to say put other two in the brackets. This sign here is going to be a negative sign, but sir, this sign here is positive. What it is that I'm doing, I'm factoring out a negative sign between the two. Why? Because the 22 here is a negative sign, so I'm leaving the middle sign out. In leaving the middle sign out, it means that this middle sign here in this parentheses is going to be affecting this 22, but it's not a problem because this negative sign times this positive 22 will give me a negative 22y, which is what I want. But when I multiply this negative sign with this negative 484, it gives me a positive 484. So in every positive number, I have two negative numbers. See, I take out one negative number here, and see, I take another other negative number here. All right. So in every negative number, I have a positive number and a negative number. See the negative number here, and see the positive number here. Besides, whatever sign is right here has to be the same sign that is right here. So the same signs in the parentheses right across like so must be the same. This sign don't have to be the same. That could have been a plus sign, but them two signs here must be the same. Then I ask myself the question, what is common here that is common there? And you hopefully will say to me 3y. What is left? Y minus 22. 3y times y is 3y squared. 3y times negative 22 is negative 66y. What is common here that is common there? Trust me, it's going to be negative 22. Sir, how you know that? All right, let me just show you something. From here, so when we're doing the question, we know that 22 times 22 give us this 484. So in the question, we were picking up this trend. 22 times 22 gives us 484. That's all got the 484 right there. All right. So when I reach right here, so I know I factor out that, and I have the same 484. I know 22 is a factor. So I'm going to have y minus 22. No, I am not surprised, because whatever is in this parentheses will have to be the same thing in this here parentheses, or else my question is wrong. So now I'm going to factor out my y minus 22 because it is common. So in factoring out my y minus 22, y minus 22, when I take it out from here, what do I have left? 3y. Do we agree?
Yes, sir.
And when I take it out from here, I'm going to have negative 22 left, equals to 0. So either y minus 22 to be equal to 0, or 3y minus 22 to be equal to 0. This implies that y is equal to 22, or here y is equals to 22 over 3. And that's how we arrived at those two numbers yesterday. That's how we arrived at those two numbers yesterday. What I also did with you yesterday was to recall that x is equals to 22 minus y over 2. All right, I'm doing all of this from memory. So let me go back and check. 22 minus y over 2. 22 minus y over 2. 22 minus y over 2. So I'm correct. All right. So now what I'm doing is to make a substitution. By the way, are you hearing me? Are you following me? Are you understanding what I'm doing? I'm recapping what we did yesterday, but I'm also using an opportunity to write it so that I don't have to, be bothered with this other computer that I don't have the charging devices for, I can send this off to you and get the thing. Is that okay, Lotto?
Sir.
I didn't hear you, honey.
Yes, sir.
No man, thanks. So you sound so,
Sick, sir.
Lord have mercy. Osh, osh.
Yes,
Trust
sir.
me. Osh, osh, my dear. See if we can get some of them tea, something there here and just osh.
Yes, sir.
I can't bother with this, you know. I mean, I've been from there, I've just been getting some sick news and flag were foreign to get treatment news and then oh god. Anyhow, be safe guys, please. All right. So I appreciate you not feeling well and coming to class nonetheless. Thank you. So this is how I get my that's my recall rather. So in order for me to get the critical, remember now, why here, let me make a notation. Spoke about it yesterday. So please note that y equals 22 and y equal 22 over 3 are critical critical values, right? So in order to obtain critical points, we need to substitute in the x equal 22 minus y over 2. All right, so that's what I'm going to do now. So I just make that notation. I've said it, but I just make the notation so that you can see what it is that I'm doing there. So x is going to be equal to now 22 minus, Lord of Jesus. Let me, you know what? I don't have much space down here, so let me use the y equals 22 first, where that we know that one is easy, and then I skip the page to do that. So that would imply that we have 0 over 2 there, which is equal to 0. So I'm going to have my critical point to be 0, comma 22. All right. So anywhere in the function I see y, I'm going to substitute the value of y, the critical value up there, because the critical point is going to be my x value as well as my y value. All right. So now, am I allowed to go across? Or is it that you have a question
Yes,
for me? All right, great. Now, oh Lord. All right, let me put it back again. X is equals to 22 minus y over 2, where y is equals to 22 over 3. All right, so this drama again. So I'm working the numerator first. Right? So I am saying 22 minus 22 over 3. And when I have a whole number and I put it over 1, it still remains that whole number there. All right? My LCM is going to be 3. Well, it doesn't remain the whole number. It now becomes a rational number, which is a fraction, but it doesn't change the value of that rational function. That's what I meant to say. So I'm converting my whole number into a fractional form by dividing by 1. So that rational number is a fractional number. That rational number now is easily manipulated when it is that I'm going to be adding another fractional number to it, right? So it doesn't remain a whole number, but it doesn't change the value from the whole number. Hope I made that clear. LCM there is 3. How many times can 1 go into 3? That's 3 times. And 3 times 22 is going to be 66. And 3 to itself goes 1 time, and 1 times 22 is 22. So I'm going to end up with 44 over 3. All right. Now, my denominator My denominator is 2 over 1. Do you agree that my denominator is 2 over 1?
Yes, sir.
So when I combine now, I'm going to have 44 over 3 divided by 2 over 1. When you divide two fractions, you invert and multiply. So therefore, I'm going to have 44 over 3 multiplied by 1 over 2. What you're trying to do, when you multiply this 2 by a half, you end up with 1. But whatever you multiply in the denominator, you have to multiply in the numerator as well. So your denominator now becomes 1. So you ignore your denominator. And this is what a lot of teachers didn't teach them. I loved my math teacher to death, or my math teachers to death, but they never showed us exactly why you invert and multiply. And I'm sure your teachers never showed you why you have to invert and multiply. The rule just say invert and multiply. And a lot of
Sir,
you,
you just
myself,
showed me.
huh?
I was saying you just showed us.
Yeah, man. And we get that rule from little boy I come up. Invert and multiply. Why do you invert and multiply? Teacher said you have to invert and multiply. I never knew what. And I, you know, in becoming a teacher, there are some things that I used to do in mathematics that I said, but if my students ask me, I need to know the real reason. I need to know the real reason. So this is what has happened. Why you invert and multiply? Because you're making your denominator to be equals to 1. So you're multiplying by the inverse of the denominator. What is the inverse of 2? 1 over 2. So how do you find the inverse? You reciprocate. What is the inverse of 3 over 2? 2 over 3. What is the inverse of 5 over 7? 7 over 5. So you're multiplying by the inverse of the number in the denominator. And this does the denominator inverse multiplying by. Why, sir? Because you want the denominator to be equals to 1. When you divide something by 1, you're not changing the number. See, I did it up here, so right here, so I'm only converting this whole number 22 as a rational number, 1 over 22. But the value of this one, sorry, 22 over 1. But the value of 22 over 1 is exactly the value as whole number 22. So this is what it is that I'm doing. I have 2 in the denominator here. I'm multiplying by the inverse. Or if you even look at it as 2 over 1, the inverse of 2 over 1 is going to be 1 over 2. So I'm multiplying by the inverse. 2 over 1 times 1 over 2 is equals to 1. But what I multiply here, I must multiply here. And this is why I end up with the 44 over 3 times 1 over 2. All right? Hope that helps. Those of you who have children going to do PEP, you need to show them this because on the performance task, performance task, they may ask them questions like those. And then you do your multiplication. 44 times 1 is 44. And 3 times 2 is 6. So that's how you get your 44 over 6. So your critical point is going to be x is, sorry, 44 over 6 is the same thing as 22 over 3 talk truth.
Yes, sir.
22 over 3, 22 over 3. And that's how we got our critical points. Any questions so far? So that's I think that's where we got to yesterday. And as I said before, I felt guilty because I didn't show you the factorization in my discourse yesterday because I didn't have it and I didn't have my writing pen to do this sort of explanation. Of course, not the pen, sorry, the cable. Cable was the same place where the pen was, and I took up the pen and left the cable. I'm so smart. But anyhow, so I never felt comfortable, and I said to myself, before I go into anything else, I move on, I have to show you this. And the concern for me came when I listened to the concerns. And believe me, this is why I get so miserable and especially when you don't talk, because I actually listen to what it is that you say. Some students were saying, sir, how would I know to do all of this? You explain this in class. I understand it, but I would not have been able to do this on my own, or better yet, know that this is my next step. And I can understand that. And then one student says, sir, I practice never practice this in order to just keep working the question over and over so I can put it to long-term memory. And then I'm saying to the student, that's exactly what I used to do when I was going to school. Exactly what I used to do. Just work the question. Same question we work a million and one time. Same question. Because sometimes when I do the question, I say, but wait a minute. When I did reach this step and all this will they do, let me try to do a questionnaire. And it oftentimes work out. Right? So just practice it. All right. So there was a next step. There was a next step. I don't think we had done this one. So D is going to be equals to f of xx xy times f of yy xy minus f of xy x comma y all square. All right. Now, recall d is greater than 0 and f of xx is greater than 0. Then we have a minimum. If d is greater than 0, but f of xx is less than 0, we have a maximum. If d is less than 0, we have a saddle point. If d is equal to 0, can't work. Well, not at this level. All right. So those are the conditions. But trust me, you think say them are going to give one question where d is equal to 0 because they know say can't work out. So them not going to give that. So expect you to get d to be either greater than 0 or less than 0. If d is less than 0, kudos to you. You know, after the no more calculation, that's a saddle point. But if d is greater than 0, remember say you have to look at the value of f of x. So why when I use f of y, the man them say the discriminant is f of xx. So we're going to use f of xx. Let us try this. What do we need? We need f of xx, f of yy, f of xy. So let's go back because I don't remember what they are. F of xx, oh Jesus, a pi of xx, anyway, never mind. F of xx is 2y, f of yy is 2x. Also do xx is 2y, and then the other one. All right, so let me see if I can remember that time. Just write it down. Recall f of xx xy is equals to 2y, and f of yy xy is 2x. F of xx is 2y, f of y, and f of xy is 2x minus 22 plus 2y. 2x minus 22 not Jesus, don't forget 2x minus 22 plus 2. So
Yes,
2x minus 22 plus 2y. Let me just check.
So I'm write it down.
Okay, all right, great, good. Thank you. So I don't have to check. Thank you, love. All right, I don't like what this thing here looks. Let me just fix it. All right. Somebody asked a question some time ago. Sir, when you did the first question, you only got a whole number. I think it was Fano. So therefore, sir, if you had in your f of xx or yy or xy, you had variables, you'd have substitute the value that you get for the variables. Yeah, man. And that's why I have f of xx xy and f of thingy bob yy, right? So it's a critical point that I'm going to substitute there. So let's just look at the first critical point. Let us look at the first critical point. Are you with me though, guys? I'm gonna sound very silent. You know with me?
Sir, we
We're with you,
blind
sir.
to the critical
Okay,
point.
good. Okay, yeah, man.
Yes,
I know. Say it again, Bijan.
No, man, I Francis. That's what I'm
Oh,
there.
sorry, Fano. All right, say it again, Fano. I didn't hear that. Say it again, Papa.
No, I was just confirming that I'm here with you, sir.
Okay, yeah. Because you'd have recognized that I would have done all of what I did a while ago from last night. And this, what I wrote on this part of the screen, you should know it, but you never see it on paper. Yeah, you saw it on paper before, but I'm just recalling the rules, and now we're going to substitute and show you, because I think Frana, you were the one who asked the question, what if you had these stuff there? All right, so look at what my f of x is going to be. Oh, sorry. So I'm doing the point, Lord, is it 0, negative? What were the critical points again? Let me do the first one first, because I have 0, 22. And the reason I'm doing it, because I don't have enough space here. I know the fractional one is going to take a lot more, so I want to use a new slide for the longer one. So I'm going to use for the point 0, 22. For the point 0, 22, it means that my f of xy is going to be equal to how much? So 44 now?
Sir, repeat for me, please.
Now I'm saying to you, for critical point 0, 22, my f of xx is going to be equal to 44, because I'm substituting the value of y into the 2y. And remember, y is 22.
Okay, sir.
So yes. Fano, you see it?
Yes, sir.
Yeah, man. And then now the value of my f of yy is going to be equal to how much?
Sir, 0.
0. Yeah. Talk truth. Why, sir? Because x is 0. I'm investigating the critical point 0, 22. So x is 0 and y is 22. And then when I look at f of xy now, rubbishness, sir. Shant, what are you doing? One night, sure. And now x is 0, so that goes to 0. So I'm going to have 22 minus 44. Talk to me. Is that minus 2y or plus 2y? It's supposed to be plus.
Y.
Plus.
And that's minus 22. So I'm going to have 22.
Get 440. Oh,
Talk to me.
no. Sir, I was getting 440 and then I made a mistake and put the says shouldn't it be 22y plus 2y?
Sorry. What are you talking about?
Sir, as in like fxy,
Mm-hmm.
they should be 22y.
Why would I put 22y when I have a value for y?
Cool.
Is what I'm asking?
No.
I am substituting. I'm substituting the values. I'm substituting the values, and I have the value of x is 0. Oh, you know, sir, see it right here, sir? That's my x value, that's my y value. So 2 times 0 is 0, so I'm not interested in it. This negative 22 is right here, so. And this 2y now becomes 2 times 22. And 2 times 22 is 44. So what I have is negative 22 plus 44, which is equal to a positive 22.
Okay, sir, I got you.
Got you. So now that I have, all right. So remember when Fernando asked the question earlier, is it right here, so? Is what the question that we did. See here? F of C of XX was a whole number. C of YY was a whole number. C of xy and yx were all whole numbers. So when I was ready to substitute it into my formulation right up here, so which is I said to you that I've given you this formula before on paper, right up here. So I could just say 4 times 6 is equals to 24. But in this rare case now, the man them say, I'm not gonna work for no money. So they gave us into expressions. And then we had to work it out for this part here now. So now we have here, so let us continue. But before I continue, are you still following? Is there a question that you have for me?
No, sir.
All right. So now I'm going to substitute into my formula. So D is going to be f of xx, which is 44, times f of yy, which is 0, minus f of xy, which is 22 squared. So D is going to be equals to 0 minus 484. Talk truth. Because I know 22 squared is 484. Me can't forget that. Because I will put time I do that another question. Talk to me. Somebody say yes.
Yes, sir.
So know that we know that D is negative. So since D is negative, what is it?
There is less than 0, so it can't work.
No, man.
It's at the point, sorry.
Right. Negative 484. Less than 0. So it's going to be a saddle point. So it's a saddle. And let me explain to you what a saddle point is. If you think of a horse, if you're atop a horse, and the saddle that they put on the horse, so it is that you can put your feet in and so forth and so on, so it makes it easier for you to ride. That's the arch in that saddle, and that's why it's called a saddle. That's how the graph will curve when you plot it. So the plot really looks like a saddle, right? So if you wonder what a saddle is one of those things that you mount on top of a horse for you to sit on. And that's how the shape of the graph is going to be looking, just like a saddle. So we're going to see that this is a saddle point. But I have another point to work with. Matter of fact, before I move, let me ask you, are there any questions?
Not from me, sir.
Okay. What about the rest of you? Are there any questions?
Okay, sir.
All right, good, thanks. And then now, if you look at it, we have another point, 22 over 3, comma 22 over 3, because we have two critical points. I have two critical points. I have critical point 0, 22 that we just work, and then we have another critical point 22 over 3, 22 over 3. Why, sir, when you give the exam about a unit fraction, because boy, the fraction them rope from a can't bother the fraction business. And I mean, sir, not me. But yes, I understand, because this one is going to be a little rough. Because we know what f of xx is, we know what f of yy is, we know what f of xy is. So when we put in 22, we know that y. So 22. So we're looking at the point 22 over 3, comma 22
Sir,
over 3. Yes, sir.
So if we take 2 days, we do this, I want question.
Oh, you're wicked. Why you say that? I could finish a question long time, Papa. A matter of fact, I'm not 2 days neither. This will be the third day we're on the question.
And 2 days at 3 months. At 3 months now.
A three class, no way to put the question. So I'm not two. You're wrong right there. But you see, but Bijan, in all fairness, we could have walked through that question a long time, box it off long time. And then you get asked it and look and say, sir, I don't understand.
Sir, yeah, we know, man. We know
that.
Analyze the question.
But when I was going to school, Papa, me used to like work them long question. You know why? Me feel like me do maths.
You're bright.
Whatever. Right, me just feel like me do some nice question and me love when one question take like a 3 folder paper. Yeah, man, me feel nice. Come and feel like me I do work. All right, let's
That's
go.
crazy.
Let's go. So we have 22. I have 22 over 3 and 22 over 3. No, my f of xx, my f of xx, xy is 2y. So this is going to be now 2 times 22 over 3. Hey, now I have 44 over 3. Remember? And f of yy, xy is going to be 2x. So it's going to be 2 times 22 over 3. That 2 is 44 over 3. And f of xy, xy is equals to 2x minus 22 plus 2y. All right, just said all of that back from memory. 2x minus 22 plus 2y. 2x minus 22 plus y are correct too. All right, now this is going to be 2 times 22 over 3 minus 22 plus 2 times 22 over 3. 44 over 3 minus 22.
22 over 3.
Which 22?
Sir, that's what I got for the answer.
Oh, when you evaluate it.
Yes, sir.
All right, let me do the long way because some of them don't get them good calculator yet. LCM is 3. 3 to 3 equals 1. 1 times 44 is 44. 1 into 3 equals 3. 3 times 22 is 66. 3 into 3, 1. 1 times 44 is 44. 44 plus 44 is 88. So this looks like 88 minus 66. Blow. Whoa. Hey, them something will come back. Oh, not 88. Them something will come back for haunt us. But this not look like 22. Where you get that for your answer, mom? Could that look like 22?
So that's what I got for the answer. 22
Oh,
over
22 over 3.
22
Oh,
over
yeah, yeah, yeah. Oh, yeah, yeah, yeah. All right. Thanks, mom. Thanks, mom. Forgive me. I just had I was wondering what it is that you're talking about. All right. So now that we know what our f of xx, f of yy, f of xy is, in order to substitute that into the formula. And f of xx, xy times f of yy, xy minus f of xy, xy all square. I'm going to have 44 over 3 times 44 over 3 minus 22 over 3 all square. 44 times 44 equals 1936 over 3 3 is 9 and 22 is 484 and 3 3
184 over 3.
over 9.
So that over 3 is the answer.
No, over 9. We
Oh,
have to square the 3 also to give you 9. So it's 484 over 9. And then no, the denominators are the same, so I can write back my denominator and just perform the algorithm of the numerator. So that's 1936 minus 484. And I'm going to get 1452. Sir, when I get back them something here so much time, sir. The 1452 come back, sir, because I recognize that number 1452. Sir, will we always get that? which is greater than 0. No, you won't. You won't. It's just it's a play on numbers. It's just based on what the numbers are, but it's not every time you can get back the 484 and the 9 and the 1442, 1452, because the 1452 came about when we were prime factorizing up here. So, all right, but it will not always work out like that. So d is greater than 0. So we need to check the sign of f of xx. If f of x is f of xx positive or is it negative?
Positive.
Positive.
It is positive. So d is greater than 0 and f of xx is also positive. We have a RELATIVE MININUM. We have a relative minimum. And that's the end of that question.
So we have to do each critical point by itself.
Yes, my love. Yes, my love. Yes, my love. Because you have to classify each critical point. So Lotta was the one who gave us this question. And she says, sir, you see a question here, given a part A and part B, I want blank something to other 30 marks. So this is it. You're not asked to find out the little something them like what sir asked you to find out the last time around. So remember what you need to do. You need to perform your 6 multivariable first order and second order partial derivatives, 6 of them. X, Y, X, X, Y, Y, X, Y, Y, X. You're getting points for those 4 stuff. So you start all of those. When you do those, you're going to set your denominator, rubbishness. You're going to set your first derivatives equals to 0 and then solve simultaneously. Sometimes you can get linear equations where you can use the elimination method to solve. Sometimes you can get one to be quadratic and the other one linear. You can use a substitution method for the simultaneous equation to solve. And then in the other case, you can get 2 non-linear equations where you just have to go work. In this example that we did, we were able to make one variable the subject in one equation, and then we go ahead and substitute it into the other equation in order to get an expression for the other variable. All right? And then what we're going to be doing now is we're going to be using those, our values, which really gives us our critical points to classify what it is. All right? And the classification, we're going to be using a formula D, which is going to be equal to f of x, x, xy times f of y, y, xy minus f of xy, xy, all square if D is positive. You have either a relative maximum or a relative minimum. To differentiate between the two, you check your f of xx value. If your f of xx is positive, you have a relative minimum. But if your f of xx is negative, you're going to have a relative maximum. As shown, if your D is negative, you just go ahead and write on saddle point. You don't need to check f of xx or f of xy. Just go ahead and write on your saddle point. And if somehow you get D to be equal to 0, then you know the question cannot be solved at this level. You have to use additional methods to evaluate the nature of the critical points, pointer points. Question, do you have any?
No. So the question finished, right?
Yeah.
Okay.
It's now finished. And what I just did a while ago was to do a quick recap as to what it is that is expected of you. But we have half an hour left and change. All right, I have two major area, not two major. I have one major area and a piece of area that I need to do with it to finish off the syllabus. And the piece of area I can do in about 20 minutes. It's really not bad. I mean, the truth of the matter is I could do that piece of area now and get it out of the way. because it's on multivariable function, but I know you know it, but I don't want to do that. I want us to work through, and I keep doing this, I want us to work through another question. I want us to work through another question. There's something I did say to you that I was going to point out something to you. I don't think I have another question, I did something here and I said I wanted to point it out. I wanted to point it out to you. Yeah, I don't have another question. So let me point out what it is that I discovered. And then no, I do have another question. I can give you this question that you just box off quick time for me. All right, I do have another question, but let me share this tab instead and just point out something to you as I sat down and did these questions for you. All right, so I want you to look here. All right, so look at this one here. It says in May 2012, it says the annual labor and automated equipment cost in millions of dollars for a company's production of television sets is given by the function CXY is equal to all of that, where X is the amount spent per year on labor and Y is the amount spent on automated equipment, both in millions of dollars. We did this question before?
I think we did something similar to it.
All right,
Yes,
good. All right. It says determine how much will be spent on each year to minimize this cost. You see this word minimize, as I told you, that word minimize is because they would have done the question and you would know that the critical point is going to come out to a minimum. That's why they were able to use a minimize point. What is a minimum cost?
And the minimum would in this case be like that would be the higher cost.
Yeah, but it's
we did it already.
Yeah,
Sir,
man.
we
What
did
is
it already.
Yeah, we did it already, right? So look at what I'm showing you. Look at the point I'm making. I'm almost ready the question. So this is the point I'm making. So this is May 2012, May 17, 2012, as I would have seen it on a past paper. We went through the question and we did the
This
question.
looks like it come back 2017. So the one that we did was 2017.
But hold on, it came back in 2010.
Yes, and see it there again, 2010.
Right.
And I think it's in 2017.
But guess what? And that's the point I'm making. But guess what? In this case, they gave you an additional part of the question inside of it. Find the total. This was a question that we did actually. This is a question that we did. This is a question that we did in class. And this I'm showing you that the question came in 2010, May 13, 2010, as I would have seen it on the past paper. So this is a question I did when I did the 3 parts to the question. And somehow
that's the same one in 2017 too, you know, sir. Go up a little more.
Hold on, the love. Because I didn't clear
the one with Z, Y, and ZXY. Yes, sir. This is 2017.
2017. So you see what you see the point I'm trying to make across? Because this is a paper, and she's correct. You're correct, Lotto. This is 2017, August 10, 2017. And so that was the first question I did with you. See the question here? Good of Bath, and I did that question in its entirety with you. Now, 2017, let me just show you something here now. That very question, show this tab instead. This question that I'm looking at, that I did with you, also came in 2010. So the question came in 2010, May 13, 2010. It came August 10, 2017. And the same question came May 17, 2012. 3 times them give the question. 3 times them use the same function. This one, them ask you only to do two something. I would have done them 2 something. Yeah. But the other 2 questions are exactly the same. Exactly the same. That's the point I'm trying to bring across to you. So I'm saying to you, it is important for me to work these questions with you. I cannot tell you. I submit a question, you know. I submit a question to CCCJ as is requested by me. But CCCJ may decide, say, me don't like Mr. Sham question. So we're going to use one of
But
the
wait,
for the
wait,
question.
wait, sir, hold on. Since it's that, is that the case for all math teachers across every institution?
What I'm saying to you, Crosswell, is not just math courses, it's right
Yes,
across
sir. It's
all the
not
courses.
only maths courses, because when we
All
were
across.
studying software engineering, and if you have the past paper, you see a pattern of how the
Yes,
questions are set.
yes. But can I tell you a secret? It's not just Excelsior or the CCCJ.
All
Because
this,
when I was studying at the university too, I'm telling you, when exam time come, me go photocopy my exam papers because I would have seen a trend and say, okay, on another question here. I again love it too. And I will do the question. And for sure, the
It will come
question
on
will not
the
come into,
paper.
yes, sir. Yeah, man. So you have to work the past paper. So when I'm teaching you guys, that's why sometimes it makes sound annoying when sir every day I'm come to class and ask the past paper. Yeah, because Uno have more past papers than I have. So when they give me the past papers, I go work them in a class for you because they may come back. So I have no more questions to show you. You know why? Because every year them keep carrying them same questions here, right? And I do the question on the lesson. I still do the question because I want to show you. You get the same answer. Now there is an Educasoft question that I pulled from the system. I don't want to project it because I did the question and there goes the function 3x cubed minus y cubed minus 36xy plus 27 minus y. 27 minus 11. 27y minus 11. Now, sir, we're not seeing any right up. Hello. You see this question here is like the question that Lotto says, sir, a 30-mark question upon paper and not giving a part A, B, and C something. It just give a one full something. The function here is like a one full something. So you don't have to work about no automated gate and no subwoofers and you know, just work that question here. Find the six something and listen to me. We have done that question in a class. So that Bijan can see the question can be done in 15 and 20 minutes. So you have the information, work with something. Do the six differential, substitute, set your first differential equals 0, solve the simultaneous equation. When you do the simultaneous equation, then you go ahead and you're gonna find your critical value. You substitute it into the original function to get your into the other simultaneous equation. You're going to get your other value for your critical point. So if you have your critical, you can substitute to get the other critical value. Then you can put both critical values together to get your critical points. Then you can test it with D to classify that critical point or those critical points for me. On your mark, get set, go.
Sir,
Yeah, man.
sir, I got kicked off, so can you repeat what I was supposed to
No, I'm
repeat?
just saying that I'm projecting the question to the bottom of the page. CXY 3x cubed minus y cubed minus 36x plus 27y minus 11. I want you to go ahead and complete this question. Find the critical points and classify them for me, please.
Okay, sir.
Thank you.
Mm.
Finished.
Yes, Courage. Who said sir? Somebody said sir?
Yeah. Yes, sir. I said I'm finished.
Oh, fabulous. Bijan, you see, said the question can done in 5 minutes?
Sir, I encourage that, sir. So,
I knew you were going to say something like that. All right. Okay, thanks, Courage. Hold that Courage. I'm going to give them another. It's 8:45. I want to be able to do the question or project the question to you. So I'm going to give you guys another 5 minutes, and then we use the 10 minutes to just wrap up. Please, hurry up, hurry up. Thank you. All right, you guys are supposed to be finished by now. Are you still working? Finished? Who else is finished? Them not talk to me, Jesus. Who else is finished, guys?
Sir, I'm stuck, sir.
You're stuck.
Yeah.
All right. Um, you are stuck. You are stuck. Okay, where is all right, do me a favor. I am gonna ask you to what's the what's the sorry, my writing tab is not responding. What's the function, please? C of xy.
We have xy equals 3x cubed minus y to the third minus 36x plus 27y minus 11.
Do you agree with that?
Sir, 3 3s and 9.
Three, but it's three times.
3 times 3 is 9.
It's nine.
Three.
Where I put that? It's not three cube. It's three is nine. You don't know that?
Sir,
Wait,
sorry.
wait, sir, hold on. It's not 3 times 3, it's 3 cube.
Yeah, but you multiply the three by the three.
Before we move on, let me just do it myself.
No, but don't look at the screen.
Three cube is 27, sir.
No, but I'm saying to you, I'm not cubing three. I'm multiplying the three by the three. When I differentiate, I'm multiplying 3 by 3 to give me 9.
Oh, I see now. Yeah, I just realized it.
Okay. And Joe, take time with me. Don't come ask me no. 3 times 309, sir. Sure. You know the people, them good Wednesday night.
Sorry, confused me a while ago.
No, man, trust me, I confused myself a while ago. All right, I'm happy that you guys are alert. And then this is going to be 18x, don't?
Yes, sir.
That's correct?
Yes, sir.
Agreed?
Yes, sir.
Agreed?
Yes.
Both equations are nonlinear. So I'm going to solve. So I'm going to say 9x squared minus 36 is really the difference of squares. So I'm going to have 3x minus 6, 3x plus 6. Can you see that?
Thank you.
All agreed so far? The rest of you agree?
Yes, sir. Yes, sir.
Okay. Because 3x times 3x is 9x squared. And 3x times 6 is going to be 18x minus 18x. and 6 times 6 is 36, negative 36. So I'm going to say 3x minus 6 is equal to 0, which implies 3x is equal to 6, which implies x is equal to 2. And I'm going to have 3x plus 6 equals 0, which implies 3x is equal to negative 6, which implies x is equals to negative 2. So what it said, what it is saying to me so far is that I have two values of x. I have two values of x. I'm going to have some values of y now. And that's where I may end with you and just ask. I just want to start you off and then just ask you to finish off. I'm going to send off this document to you just before class ends, and sometime later I'll get some food and so forth. I will finish the question and update the document for you. I don't want to keep you beyond 10 past, 9 past, 5 past, sorry. I don't want to go to 10 past. And then I have negative 3y squared plus 27 is equal to 0. How do I treat with this one? I'm not allowed to right. I'm not allowed to do any sort of cancellation because it does not support what it is that I'm supposed to be doing, but I'm going to do some factorization and see what it looks like. So here is going to be, call this negative 3 that I'm factoring out. That means I'm going to be left with y squared minus 9 okay, fabulous. This now is a difference of squares again. So this implies that I'm going to have negative 3 into y plus 3, y minus 3. This implies, of course, that's equals to 0. That y is equals to 3. And that y is equals to negative 3. Look at that and tell me if you agree with me, please.
Okay.
Agree with me?
Sure.
Yes, sir.
Yes.
So you must have faith.
Hold on, sir. You know me gonna make next. Hold on.
Mhm.
All right, so you factor. Let's see where you factor out the 3 there. So you get rid of that minus 3 there. Where you get rid of it? Where you get rid of it?
Which minus 3? Oh, no, it's fine because that minus 3 is really saying that minus 3 is equals, in my mind, it's minus 3 times all of this times this. So it's minus 3 times y plus 3 times y minus 3 equals 0. We know that minus 3 cannot be equals to 0. So it's minus 3 equals 0, but that can't work because minus 3 can be equals to 0. But y plus 3 can be equals to 0 and y minus 3 can be equals to 0. So we get rid of the minus 3. We
So
just
those
ignore it.
focus on that part there.
Yeah. All right. And then now, my points are easy to come by. I don't want to even go on another slide. Let me quinge it up right here. So I'm using this 2. So it's going to be 2 comma this 3 down here, or it could be 2 comma the negative 3 here, or it could be this negative 2 comma this 3 there, or the negative 2 comma the negative 3. And those are my critical points. So easy critical points come up. And I'm going to end it right there. You can do the last part. You can do the last part of the question for me. Or if it is that you want me to do, because since it's well, I can't finish a question. If you can give me a little bit more time, I can finish a question because There's nothing more really to be done. So is this 2? Remember, these are my x values. So my x values must be x equal to 1, x equal minus 2. So this x equal 2 is this one and this one, and it has to correspond with the y values. So this x equal 2 will correspond with 3 and negative 3. See here? 3 and negative 3. This negative 2 will correspond with the same 3 and negative 3. See here? Negative 2, the 3 and the negative 3. So I have 4 sets of values. So it means that I have to classify the 4 of them. Matter of fact, I'll have you do that. So you're going to classify those 4. And so your C of XX, you're going to have X values to substitute in there. And your C of YY, sorry, I said X values is just your X value, because it's not the Y squared one, it's the 18X and the negative 6Y, because your XY is going to be equal to 0. 0 squared is 0. So you just substitute those and you find it. By the way, Courage, are you agreeing with the points, the critical points that I got?
I think I did rubbish.
Okay. And
Yeah.
that's fine. And I like your honesty. Leave her alone. Leave her alone. She's human. She's human.
First, I know when I reached the let 9
X squared
0, yeah.
equals 36.
What I did was to make x the subject of the formula. So I just got x equals 2 and y
Aha!
equals 3.
Aha! That's what I didn't want anybody to do. And I'm going to show you what Courage said she did. And I'm going to put it in red to say that it's dangerous. So what Courage says, what Courage did was to say 9x squared minus 36 equals 0, which implies 9x squared equals 36. Right, Courage?
Yes, sir.
And she divide both sides by 9. And she'll get x squared equal
4.
Equal
So
4.
if you do that and square root it, you would get the same thing.
Yeah, but I don't want to do that. But so Courage, I don't understand what you got when you did it like that, Courage.
I divide both sides by the square root, and then I got x equals 2.
Okay, you just got x equal 2 and not the x equal minus 2.
Yes, sir.
All right. Fair enough. But when you find the square root of that though, you see one of the things is that when you find the square root of a number, you always need to look at the negative number as well. But this is the method that I don't want you to use. Don't do cancellation. Always do factorization, right? No cancellation. CAN.
All right.
Okay, so noted.
Only if you. So what you'd have done is you'd have only got 2, 3 and 2, negative 3. Right, Courage? What critical points you got?
2, 3 only, because I didn't have a negative for y.
Oh, okay, got you. So so you are not wrong. You're just incomplete, and the incomplete answers would have been because of that illegal step. So yeah, please guys, don't cancel. Try not to cancel because you're losing some values. Sometimes you cancel and you're losing the x equals 0. And the x equals 0 is also a very important critical point. Always try to factorize. Never ever cancel. Always try to factorize. Serious rule of thumb. Always try to factorize and not seek to cancel. All right. So what I'm going to do, I'm going to give you an opportunity. Me kind of hungry, so I'm going to give you an opportunity to fix up that. I will finish off the question because I'm not coming back to this slide again, and I don't want to come back to this partial derivative slide that I have here. I have 13 pages. I may go up to about 15 pages on this slide, and then I'm going to send off the slide to you tonight. I just need to go and get something to eat, and then I just finish off the questions. So I'm going to finish off the question. I already have my critical points. I just need to classify them now, and that will be the end of the question. Come next time around, and incidentally, I don't know if you get any email to say that this is the last teaching week, but just to remind you that we have business to take care of, and we have next week. And I really want to go through what I'm planning on doing is I have to give you some. I hear you guys who say don't want no mid-semester, but I mean I have to comply. What I'll do is to give you a shortened version because I don't want to. I don't have a 4-hour class with you, so I'm going to give you a shortened version on Wednesday, God's willing, because we meet at 7 o'clock, and then no, because I have to do some revision with you following that 7 to 8 test. So we can do the 8 to 9 as a little revision. Maybe what I'll do is even do the solution to the mid-semester at that point in time. But on Tuesday, God's willing, please come out on early. Tuesday, God's willing, I'm going to start class at 5 and not give you any grace period. Start the class at 5 because I'm going to do 2 topics. Easy one for the 20 minutes I was telling you about, and then spend the rest of the class to look at some rotational integration stuff with you. And that will be the end of our togetherness. All right. And then I send you off, expecting you to do very well in your exam. Thanks for coming out. Have a good night.
So, I have a
Sir,
question for you.
Go
sir,
right ahead. I comment to you. Go ahead, Bijan.
Sure. So, what if we maximize on that one question, right? Or we
Right.
pinch the rest of them? We can pass.
Duh.
If
If you're going to the exam, the question will be for 20 marks. They're not going to get a 30-mark question now because things change. So it's going to be 20 marks. If you can go into the exam and get 20 marks right here, so and you know so the 20 marks safe. We're not talking about losing a 1 mark or 2 mark, you get the full 20 marks. And then you punk up on the other 2 questions and pick up 5 marks out of 20 marks to each question. You have 30 out of 50. You must pass the course.
All right. So we just see the possibilities. All right.
You must pass the course. Not tell you the truth. Yeah, man, you're good to go.
That
Man.
is great.
You're good to go. Yes, Joe, go ahead, please.
Sir, can you remember the thing on Edicosa for me, please?
Please check it was done.
Okay, thank you.
No.
No problem.
Okay.
All right, cool. All the best, guys.
All right.
Mm-hmm.
Need to start work on that tomorrow morning.